In this video, we're going to talk about 3.5 Objective 1, where we analyze questions involving derivatives of trigonometric functions conceptually. Our first one is a special trig limit that we have. Limit as x approaches 0 of sine x over x. And they want to ask why we can't evaluate that with direct substitution. And the reason is it's not possible to use direct substitution because the expression itself is undefined at x equals 0. So that's option D here. We'll have to have a special rule for that one that we'll talk about later. Explain why the quotient rule is used to determine the derivative of tangent of x and cotangent of x until we know and memorize their derivative rules. It's because tangent of x is equal to the quotient of sine x and cosine x, sine x over cosine x, that is, and cotangent x is the quotient of cosine x and sine x, that it's cosine x divided by sine x. So that's option A here. And then where does cosine have a horizontal tangent line? And where does negative sine have a value of 0? So the horizontal tangent lines of cosine happen at the zeros of sine, which are at 0, plus or minus pi, plus or minus 2 pi, so on, integer multiples of pi. Where does negative sine have a 0? Same list, because the derivative of cosine is negative sine. What's the connection between these two observations? The values are the same because the function negative sine x is the derivative of cosine x, and the slope of the horizontal tangent line is equal to 0. So let's see. And then determine whether the following statements are true and give an explanation or counter example. Is the derivative of sine squared x equal to cosine squared x? No, it is not, because the derivative of sine squared x is 2 sine x cosine x, and we use the chain rule. So that is B, which would be sine 2x is what that would reduce down to. Question B, is the second derivative of sine equal to cosine? No, it's equal to negative sine, because the first derivative is cosine, the derivative of cosine is negative sine. So that's B. Is the fourth derivative of cosine equal to cosine? So cosine becomes negative sine becomes negative cosine, negative, let's see, cosine, negative sine is negative cosine, negative cosine becomes sine, and derivative of sine is cosine. So yes, that's true. So that's C. All right, and then for part D, the function secant is not differentiable at pi over 2. Is that correct? Yes, because secant is not differentiable at pi over 2 because the derivative is undefined at x equals pi over 2. So that's C. There we go. And that's it for this video. We'll come back next time and talk about 3.5 Objective 2. See you for the next video.